All right, guys. Can you guys all hear me? Hello? Oh, yeah. Yeah, I can see some likes. All right. Um, Hello, guys. Welcome to WebHack Meetup. And it's our second time hosting this meetup online due to the COVID-19. And to begin with, I'm gonna have some opening. Okay, give me a sec. All right. So here is our agenda for today. We're gonna have 30 minutes from our speaker Adler. He's gonna talk about how to write your own Golang Linter, and we're gonna have another 10 minutes for Q&A. And after that, we will have another 30 minutes of networking. And due to the fact that we use AirMeet this time, so we want to bring more immersive experience for our audiences. And what you can do is during Q&A session, you can raise your hand here on the right panel. And once you raise your hand, our host will take your questions and you can jump to the stage. And to be aware of that, once you raise your hand and jump to a stage, your camera will be turned on. So if you don't want to show on the stage, please turn off your camera on the button. There's a button on the bottom. And if you want to show on the stage, you can also ask your questions in the right panels as well. And also during our networking session, you can grab any table you want, grab a seat, and each table have group of 4. And once you join that table, AirMeet will show the camera. You can interact with our audiences as well, talk about the topic for today. And besides, we use HackMD today as well. And if you want to take notes collaboratively with us, you can join this URL. And our staff will also post this link in our chat as well. And for some new faces, newcomers, let me briefly introduce WebHack Meetup. And what we are doing is we try to invite different speakers from different fields every time. In the past, we used to host at different offices as well, but also due to the virus, right now we try to move all our events online. And we've been hosting these WebHack Meetup for over 3 years. And right now we have over 32 events and over 1,400 attendances joining WebHack Meetup. In our community right now, we have around 1,000 members. So if you want to follow our information, you can join our YouTube channel or you can join our Twitter account. We will post something useful or something like latest tech information in our channel. And we start doing something new. We start have some weekly newsletter, and we invite some curators from famous industries, famous companies. And if you want to get some useful information as well, you can just scan this QR code, or our staff will post the link in the chat as well. Okay, without further ado, I'm gonna introduce our speaker. Today's speaker, right now he's working at Merpay as a backend engineer. And today he's gonna talk about how to write your own Golang linter. And our speaker also has been a speaker for many big conferences. So without further ado, let's welcome our speaker with big round of applause. Yeah. So Adler, please take over. I'm gonna start sharing.
Yep. Hello. Let me share my screen first. Okay. All good. Can everyone hear me? All good. Okay. Hi. So my name is Adler, and I am a backend engineer at Merpay currently. And so, just a quick introduction on what we're talking about today. So the topic is write your own Golang linter. It's a linter written in Golang for Golang. So about the content, a quick introduction of who am I, what is a linter, how to use it, and the most important thing is how to build a linter on your own. And after that, if there's time, we'll do a little bit of demo, and I'll give you some resource links. Like if you are interested in this kind of topic, what are the other resources you can use and to check and to reference to. So a bit of information about myself. My name is Adler, and I'm a backend engineer at Merpay. In my career, I mostly use Ruby and Golang. So here's my Twitter handle and my GitHub account. I have a blog as well. And last but not the least, I'm a meme user. I use a lot of memes at work, and I follow 9gag and other stuff. You know that. Um, but that's not the point. So in this presentation, there are some memes that I like to use. So I hope it's not too boring. So after that, let's quickly jump into our topic today. What is a linter? So for those of you who are already familiar with what is a linter, then I'll just make it quick. But for those who are not familiar with it, I'll just make sure everyone is on the same page. So based on Wikipedia, a lint or a linter is a tool that analyzes source code to flag programming errors, bugs, stylistic errors, or suspicious constructs. This is kind of a bit too complicated. I wouldn't use that explanation. So I would say linter is something that makes your code look good. It also helps you to debug the code. Also, a linter is usually a command running against a package or a file. It might be also in other forms, like if it's a service, it can be integrated into CI or into your GitHub organization or repository, something like that. So how to use a linter? So in Golang, the most straightforward and simplest solution is govet. Govet is not veteran. Golet is a tool, it's a command that you can use to analyze and to improve your code quality. Actually, I'm not sure why it's called govet, because I searched several places and I couldn't figure out why is that called vet. Anyway, it's not the point. So with this command, this is built in, no third-party tool required. You install Go, it's there, you can use it. So how to use it actually? Here's a quick example. So we have a very basic Golang file here, which is the main package. It's a very simple function that has only 3 lines. The first line is return, and the third line is to print full string. So what's the problem with this code? On the first line, it returns directly. So the third line is not executed at all. It might not be a problem in this small program, but if there's a big project and something like this happened, and unfortunately you don't have a test to catch it, and then some error occurred on production. During this time, this kind of linter tool will be really helpful in this situation. So if we run this command, on the first line we say go run main.go, it does nothing because it returns directly. So after that we run go vet main.go, it will tell us on line 8 we have an unreachable code. So this is really helpful for us to figure out, okay, what's the problems in our code? What are some potential problems in our code that might have issues in the future? Another great example is Golang CI lint. This is another tool. This is a kind of like a library of all kinds of linters putting together. So there are around 40 linters currently, and it is a command, so it can be easily integrated with CI. If your code base needs something more, in addition to its built-in Golang vet tool, you can check this out. I think there are a lot of helpful tools in it. Let's give another quick example. So in this file, we have main function, and we have another private function called find current time. They do the same thing, but find current time is not called. It's basically a dead code. If we run this file, it might not have any issue, but it's kind of weird that it's a function and no one's using. It's going to be a problem in the future where when people see a huge file and we have 100 functions and 10 of them are not being used, then it actually not a good way to maintain it. So for improving the maintainability, we probably want to remove this function. So we can run Golang CI lint run main.go. It can catch the error for us, not the error, but a problem or a potential issue for us saying this function is not used. Please remove it. Okay, so after we understand how to use a linter, let's talk about how to build one. But before that, we probably want to answer the question of why do we want to build a linter? Because we have so many options out there. We have 40 linters in Golang CI. We also have about 20 to 30 tools in the built-in Golang vet tool. If we have so many options, why do we want to build one? So in the scenarios of if you have a project that has a specific rule, or in your organization, you have some rules that is very specific to your project, that you only can solve it not with other tools, but you have to build your own. So in this kind of situation, you probably want to build one from scratch. So here's a quick example, a real life example that our team has some rule that we want to build our own linter, which is called anti-depth. So this is a dependency management rule, a dependency management tool that helps us to figure out which dependency is being used in what package. And in some cases, we don't want a package to be used in another one. So what is that kind of situation that we want to prevent this kind of situation? It's like Gandalf saying there that you should not import this package. Let's say we have a project that is using kind of an MVC structure. We have controller, view, model. So there are many different types of MVC. I'm just taking a random MVC here. So let's say we have a controller, and that is going to use the data from model and provide that data to view. In that case, we don't want the model to use the function from the controller because controller is like a subject, but the model is an object of passing the data to controller. In the same case, we don't want the view to access the model directly. We want the view to take data from the controller. So in that case, these two red arrows are the things that we are trying to prevent. In that case, we use this anti-depth to specify the rules that we trying to execute. We have a path saying, okay, in our model package, and we have an anti-path which says we don't want to import these packages. In common cases, there will be a problem like immediately if you do this because there will be an import cycle. This is an easily detected problem. But in our project, there are some cases where problems will not be found easily when it's first committed. It will probably be found about 2 weeks or 4 weeks later. And at that point, there are already some packages being imported. So there will be some extra time, about 2 or 3 days required to fix the entire thing. So this is a helpful tool for us to fix this kind of problem. Okay, so after we know why do we want to build a linter, let's talk about the most important part, how to build one. I know this is kind of the most boring thing in this presentation, but this is also the most important part because there are a lot of details. I will be trying to not to talk about too much details, but to just give you a general idea of how is that done. If you're interested, you can go to the resource link and to other articles that I provide, then you can check it out. So how are we going to do that? Are we going to read the file and analyze each character, like on the entire file? No, we are not going to do that. So if you ask someone who has done that before, he will or she will probably tell you saying, we don't do that here. So the way or the steps that we are going to do it is, the first one is we parse one or multiple Go files or the entire package generally. The second one is we are going to go through each AST node And the third one is we're going to calculate and print or return error if necessary. So here's a new vocabulary. What is a AST node? This might be a little bit confusing. So an AST node is a abstract syntax tree. So in every programming language, if a programming language is going to read or understand a file or a piece of code, then it needs to translate this file into a AST so that it can understand what it's doing. So in an AST is a lot of nodes. So a node is the minimal unit of a source code saying, okay, this node and that node is doing something. It can be combined together and to, for example, 1 plus 1. Then 1 and plus and 1 are 3 different nodes, and they're going to work together to be able to run the program. So let's talk about something practical. In Go, how are we going to read the node and how are we going to understand it? So let's take this very simple package, for example. We have a package here, which is called foo, and we have a function foo, which do printing. The only thing it does is printing, hello, foo. Okay. So here we are going to use a tool from Go AST package, which is a inspect function. So inspect function under the hood is to walk through all the nodes within a file, and then we will decide how are we going to take each node and then do something or to process it. So how are we going to do it? Let's say we have a file here, a main function here that we can process a file. This is a little bit complicated, so I would suggest you to focus on only two things. We have a file here, and we have a parser package, which is go/parser. The parser package will parse a file and have this f variable, and then we pass this f variable into ast.inspect function. And after that, we have another function, which is passed into this ast.inspect function as well. It will have a node here passed in as an argument, and then we'll use this node to process what we want to process. Okay, so within that function is where the magic happens, because it will walk through all the nodes. So I would say when I first saw it, it's like a black magic to me. Okay, so in our use case, we are trying to print out all the nodes in that simple file to see which node is what. So in this function, we do if node equals to nil, return true. This doesn't make too much sense here, but just keep it there. The only thing we do here is to format.printf, and we print out the type of the node, and then we return true. The true or false here is not like really matters here because in most cases we want to return true, because when it gets true, then it will start to process the nodes within this node. Yeah. Okay. So after we know how to process it, let's take our file here, and then we run the command. So these are all the nodes that we can find in this simple file. This is a little bit overwhelming because there are a lot of new terms that we don't know, but there are already something that we can smell like, okay, I know this, I probably recognize this. For example, we have a import spec at the beginning, which directly associate to this import. We have a function declaration here. It's clearly a function declaration here. We have a block statement, which points to this one, and we have a expression statement. Within this expression statement, we also have a call expression, select expression, identifier, all this kind of stuff, but it doesn't really matter here. We just need to know how the nodes are look like in the file. Okay, after this one, let's do something practical. Only with a practical example can we know that how a linter works. So let's say we are catching unnecessary blank lines at the beginning of a function. So that sometimes happens to us. Like when we write a function, we leave some blank spaces at the beginning or the end of the function, and some team doesn't like it. I personally don't like it. So that's why I come up with this idea. So let's say we have a file here, and which is another foo package. It has two public functions. One is foo function and one is bar function. The first function has a new line or extra new line at the beginning, and the second function does not have an extra new line at the beginning. So the purpose of this program that we're trying to build is to run it, and then it will print out a message saying there is an unnecessary new line at the beginning of a foo function, but not the bar function. Okay, so how are we going to do that? The most straightforward logic that come up with I will come up is that is there a way we can check saying, okay, is this node a blank line or not? Unfortunately, there's no way of doing that, which is pretty bad. So the way we're going to solve it is with the line number. We are going to take the opening bracket, which is the opening of the block statement. We're going to take the line number of that and the line number of the format.println function call, which is the first statement within this block statement. Kind of a bit confusing, but you'll get to that. I mean, I'll get to that. So with the same ast.inspect function, this is like the complete source code of how are we going to do it. It's a bit overwhelming. Let's not be worried about it. Let me just walk you through a bit, not too detailed, but the general idea. So for each node that is passing within this function, we will check, okay, is this node a block statement? If it is a block statement, which means if it is a bracket. So if it's a bracket, then we are going to check the line number next. If it's not, then it's fine. We just skip it. So after we know it's a block statement, we are going to check the number, the line number of the opening bracket. We will get its position, and we use, these are pretty ambiguous here because it's not in the screen, but out of the screen. But if there's a time for demo, I'll show you that. We have a position function that to check the position and then to retrieve the line number from that. And after that, we will get into this function and then check all the statements within this function. And we'll get the first statement and then check its line number. So at the end, we can see that we got dot line to retrieve a line number. And then at the end, step 3, we calculate the difference. First, we get the statement line plus 1. Is it smaller than the first statement line? If it is, excuse me, if it is this, if it is more than, it's bigger than 1, it means there's something in between. If there is something in between and it is not a node, then it means it's a blank. If it's, if the block statement plus 1, the line number plus 1 is the first statement, it means there is no blank between these two statements. So that's how we're going to do it. So we can run this program and then we get the result that we want, saying unnecessary new line at the beginning. Foo, yay, it's done. So this is just a quick walkthrough of how we do it. I know there's not much time there, but I'll just quickly walk through like how to enhance this kind of program with Go analysis. Because for Linter, it's really hard to make everything from scratch. So Go, the Go team also provide a framework for us to solve this problem, to kind of like bootstrap your progress, that you don't have to build everything from scratch. So this is a program. This is a program that is doing what we just did, saying, okay, we parse this file, we check the first line, we check if there's the first line is a blank line for each function, but there are several issues that we are trying to solve here. So if we are going to parse multiple files, but not only one file, how are we going to do it? Also, if we're going to integrate it with other linters, how are we going to do it? Because there's definitely the real situation is much more complicated than we have here right now. So actually, we can do this from scratch, saying, okay, wait, I'll just do this and integrate with other linters. and I'll spend another day to rewrite the function and then to make it accept multiple files or multiple directories. But we don't have to do that. Since there's a framework already for this, which is Go Analysis, it can solve the problem for that. It can read files automatically. It's integrated with other linters and integrated with other tools perfectly without you having to implement other code. So a quick example of how to do that here is you don't have the main function anymore here. You extract your code into a different package. You name your package, you have an analyzer, you have a run function attached to this analyzer. And here you can see that we have this function basically will accept a pass variable here. And then this, argument, the pass argument has files here. And for each file, we do something. It's a very convenient function that we don't have. If we are parsing the entire package, we don't have to specify saying, okay, I'm going to parse this file, and that file. It's automatically done within this argument. So for each file, I'm going to do something, which is the function that we just used, axt.inspect. So when we do this, we can pass in the code that we just used, and then to run everything here. And after we extract the entire thing to another package, we have the main package here. And the main package is very simple. We have a Go Analysis single checker here to run our analyzer. This is a good thing because if we have multiple analyzers here, we can string them together with another package called unit checker. I don't have the slide here, but if you're interested in that, you can check it out later. It also offers some kind of command line arguments for us, command line flag, not argument. So if we run go run main.go without specifying a package, it will say these are the variables that we can use, not variable. Why am I keep saying that? It's flag. Some of them are very helpful. For example, we have a profiling here saying CPU profile. We have main profile that can help us to profile our performance and to tune the performance of this linter. We also have the most helpful function, which is fix. You can apply all the suggested fixes within that, following the format, and then fix the file using the suggestion. This is really helpful here. And we can also have a JSON output from the linter. If you ever used Golang CI lint before, or other or the linters in other programming language, that the linters can output some format either in YAML or JSON, and then some platform can take it, like GitHub or other platforms, and you can use that information to integrate it with your source code platform, like GitHub, which is pretty useful. You don't have to write any code for that. Okay. So if you pass in the package that we just used, like the example package, it can also show you the result by passing in the entire package. You don't pass in a single file. You pass in the entire package, which is pretty useful. Okay, so here comes live demo. I'm not sure I have time. Like, I do have time? Yeah, if I have time. If I don't have time, please stop me right now.
Yeah, go ahead.
Okay, so I have time, and then live demo. I too like to live dangerously, you know. Okay, so I'm not going to do anything too fancy here. Even though I like to live dangerously, I don't want to mess up in this. So let's say we have a project. We have an example.go, which is the one that I just used, which is pretty convenient. And I have two files here. One is inspect main.go. And in this file, we can see that it's the thing that basically put in the slide here. And I have another file, which is the one that is already extracted into the extra line package here. The content is the same. It just extracted into another package. Worker file, I'll just skip it. It's the same as ast.inspect, but it's called a worker function. I'll just skip it for now. So for inspect, let me just do it very quickly. Let me just do, so we have some files here, so I can go run inspect main.go. And then because it is trying to, because it's already built in the argument is already built in here, example slash example.go. So I don't have to specify a file here, which is really convenient. It says it successfully printed out the result that we want. On line 8, we have a not a, a extra blank line here, which is not line 8, which is line 7. Anyway, it needs some bug fix. And for another file like this, let me just run it through. Go run main.go. If I don't pass in any argument, it will say, it will show me the usage of this package and exit status 1, which means I don't have anything. So I'll just do go run main. Oops, let me just return it. Go main.go. Go run main.go. What's the package that we're example? Let me just make sure. Yeah, example package. And after we run it, it will tell us unnecessary new line at the beginning. Foo. Yay. So basically, that's what I'm trying to demo, which is also the thing that I just walked through earlier. All these things, and that's it. So for some resources, if you want to check out the source code of this one, I put it on GitHub. I'll share the slides later. If you're interested, you can check it out. I have an article that I wrote on my personal blog and also on Macari Engineering blog saying about an introduction of the Go Linter with a bit less details, but it should be enough to give you some idea of how to write a linter. And there's another post that's written by a blogger, and he uses a Go analysis tool to write a custom linter. Basically, he walks through from st.inspect to Go analysis. Basically, it was just I just explained, but he got another example. So if you're interested, you can check that out as well. So this is all I got today. I hope you enjoyed that. Thank you.
Ooh, nice. Yeah, thank you, Adler.
Yep.
I think for our audience, it's quite a really practical talk for them where they can apply in our daily work. And because we have much more time than we expected, probably for our audiences, if you want to join on the stage, you can raise hand, and then I'm gonna take you. Okay, oh, somebody raise hand right away. All right, here
Oh,
we got one question from Greg Wong.
okay.
Hello, Greg.
Can you hear me?
Can you hear us? Yeah, we can hear
Yeah.
you.
So I just want, first, I think because Golang has a built-in SD that makes it really simple, but I saw there's a runtime type setting. Like you check the type run at the runtime.
Yeah.
So whether when you are working on AST or linter or something like that, you need to do that a lot.
Yeah, that's the ugly part of linter, that because the data is passed in by reading a file. So it's like when you're working on a web application and you take data from how is that called? From database, either database or a third-party API, you have no idea what you're dealing with. So you have to use type assertion to do to get the data that you want. It's the ugly part, but for most linters, it has a specific purpose that you know what you are looking for. So if you can manage it in a there's always a space for you to improve your code and to manage it to improve the readability. For my example that I showed earlier is not really a good example because I have to show, okay, so I have to assert that, and assert this, assert that. But the example I showed earlier, it's not too complicated. only does a type assertion on block statement. It might, if you have a linter that's very complicated, that doing multiple layers of assertions, that might be very complicated. But yeah, we can think about how to improve that, like case by case on different case. Yeah.
So whether this actually is the second question, whether it's possible to use the Go ASD or similar built-in features to make another language's linter or parser or compiler.
I would say it's very hard because Go Linter is only doing. It's very convenient for Go Linter to parse Go because for Go compiler is using the same thing to parse Go files and to interpret Go files. I know if you are going to do that for other languages, you have to read and to interpret that language into the things that Go can understand. Just like what if I know C, like programming language like Ruby or Python, they're built in C. So for those languages that you can build a linter from C for C, and you can build a linter from C for Ruby. But it means that you have to have a way to understand that language first.
So actually, the Go parser handle and map to ASD for you, so you don't need to handle parsing. That's why it is much easier, I think, according to what you say.
Correct.
Yeah, because usually when you got the ASD, the most difficult part in the first stage already done.
Yeah, correct.
Yeah. Okay, I see. Thank you.
Thank you.
All right. Do we have other audience want to join our stage? Ray, do you want to join? You have the questions, right?
You don't have to force him.
Yeah, you can raise hand on the right panel, and if you raise, oh yeah, here you go. Hey, hello.
Hi.
Cool. So my question is, do you integrate this linter to your IDE environment in your company, or simply just integrate this into your C continuous integration pipeline? Can you share a little bit of experience on this?
Yeah. For the linters that we build, we didn't integrate it into our IDE or the editor because we in our team we don't force that. Personally, I do Go because personally I use Vim, so I have some plugins that do that for me, which is GoVet. But we do have that integrated in our CI, which after we deploy to we push to GitHub, and then it will trigger the CI for us, and then we separate that into different stages. We have test, we have build, and in the build stage, we will trigger multiple linters for that. For our team, we use Golang CI lit, we use Go consistent, and there are other linters that we use that built by our team. Yep. So basically, mostly in CI, but not locally. But if from my experience, it's that before we push to GitHub, in addition to running tests, sometimes we just run the linter first to make sure that it's not going to fail during the linter stage.
I see. So the reason I ask this is because I'm working on a project that very similar to this. My project I'm working on is the LSP integration in Haskell for Haskell, and we've already had linter working and integrated into the IDE. But the problem is that we also have type checker and we have linter, and the type checker is also behaves like sort of a linter. So we have multiple linters work together within IDE. So they somehow like a little bit interact with each other. The user experience is not that good. So that's the reason I ask you about like to want to know your experience on this.
Okay.
Working on simple things.
Yeah, unfortunately, I don't have experience working with like linter integrated into IDE, but I can imagine that's a terrible. I mean, that's a very hard thing to do.
Cool. Thank you.
Yep. Thanks.
Thanks for the question. Anyone else want to join the stage? Okay, if we don't, oh yeah, we have Greg again.
Me again.
Nice to meet you again.
So, about compiler or language, I will become very
Cool.
Yeah. So because actually the space problem is an interesting part, like Ray and me chat in the channel. The thing is, usually in some language, you can ignore space and even line number safely because the EBNF, the syntax node doesn't require that, so that can be ignored. Usually for debugging and for formatting and even linting, you need that information.
Yeah.
So I just wonder how, if you want to write a linter for like a document in comment, is it possible in Go? Like Java doc, right? It can extract the document from the comment, but comment will be ignored if you don't have the proper options or tools usually.
Yeah.
Yeah.
So I know it's possible in Go because for processing, for parsing the file, if you look at the, how do I say that? Though after it's parsed, there's a file. There's a how do I call that? A type that is returned called file st file, and in that file there are comment groups, and you can check the comment groups and to analyze data. There's a great a great linter that Golang CI lint has, which is to check whether you have commented out code in your code base and to suggest you to remove that code. I'm not sure what's the dark magic they use, but they certainly can analyze the comment and to judge or to say that whether it's a code or comment. So if you comment out a code, then probably they get the comment and they remove the comment and they try to parse it and see if it can work. If it can work, then they know that it's a Go code. Then they will suggest you to remove it. But similarly, if they can do that, I believe it's an open source world. So I believe there's always a approach to analyze the comment and to see, to look for what you want to look for.
Yeah, it's actually sometimes open a very interesting door that golfers usually hate. Is you can use this tag for AOP. You can use something like a Python decorator in comment, like what Java did in the past.
Yeah.
Because sometimes golfers like to keep things dumb simple, but repeating code is another pitfall. So if you can use it, then you can make your own AOP tool to wave in the code.
Yeah.
Of course, it's sometimes dangerous, but I mean, this is another possible way to use a tool or abuse the tool. Yeah.
Yeah. True.
Yeah.
Cool.
Okay. Thank you.
Yeah. Thank you.
Thank you, Greg. Oh, we have another audience. It's Ray again.
Yay.
Hey, hello, Ray.
Hi. So I suddenly remember that I have another question that is
cool.
kind of similar to the question I asked. That is there a plan to or have you implemented suggestion, because there's if there's a linked warning or linked error, and definitely you know how to detect it. You probably will have some way to understand how to fix it. So I need to.
It's all right.
Hey, go ahead.
We all have the same problems sometimes.
Yeah, I'm back.
Yeah.
So that's the question.
Sorry, can you say that again? I think I got distracted.
Oh yeah. So the linter, once you have the linter build, and you run a linter on the source file, and let's say there's a warning that produced by this linting process.
Okay.
And then you probably know how to fix it because you write the linter. For example, the empty line between the first line is the empty line in the function that should be able to remove automatically.
Yeah.
So is there any plan of this, or have you built anything of this?
No, I have not built that yet, because for fixing, it's usually a complicated process that if you enforce something and then you try to fix it, I mean, it's good for personal use, but it's not something really good to push that into a team, because you cannot force someone saying, hey, you should do that, or like you interestingly, that if you can, like, someone push the code and then you have a linter and then you automatically fix it and then push it, it's kind of like disrespectful of others like work. So that's not usually something we use at the team. But I got your question. I haven't tried that before, but that's an interesting thing that I haven't thought about implementing that, because that's kind of, I know it's gonna be very hard. Like you have to know how to make changes based on the code, and then you have to save it, like make the changes, save it, and make sure it's not like breaking the things. But that's an interesting topic that I probably can try later. But for now, I haven't tried that before.
So my experience that in our company, there's several languages built, including in linter and formatter. I think the empty lines can be considered as the formatting problem. So for formatting, like in front end, the JavaScript paradigm, sorry, I need to go for a moment.
Okay, that's all right.
I thought he's going to talk about prettier, and which you can fix the formatting related issues automatically. And I think in Golang, you guys already have Go format to do those stuff for you guys, right?
It's already doing that.
So I'm wondering for things like deleting those blank lines, is it possible you can add some customized rules to your Go format in order for team consistency?
I am not sure if we can do that. I mean, for Go format, I'm not sure it can be customized. I think that's a tool that is already there, that not for customization, but I'm not sure that we might be able to do that.
I see.
And the reason that your point is valid is that it's kind of a disrespectful for the author of this diff or this pull request.
Yeah.
But the point is that the problem is that the linked arrows might queue up, like because engineers might some engineers might simply just don't care, and they just that this linked arrow passing through the
I see
to it. And later, because this person doesn't care. And later,
I know.
So multiple person doesn't care. The linked warning just queued up, and nobody cares about the warning anymore. So that will be a problem.
Yeah. I would suggest that to integrate that into the CI process will be a good idea, because just like you have to pass the test to merge to master branch, you have to make sure that code follows a certain standard before it can be merged into the branch. That would be a good idea to make sure everyone's on the same page, and the code at least not doing something crazy. It can pass the linter, and to make sure the quality has reached a specific standard. That would be a good idea to keep everyone on the same page.
Cool, thank you.
Yeah, cool.
Yeah.
Wait, Ray, can you stay a bit? Because inside the chat, I thought you talk about there is a source mapping in parse AST, and I'm personally also interested in this topic. Can you elaborate more about this? Like, what does it mean by source mapping in parse AST?
I don't have many experience on the parsing files, but I've looked into 3 languages, JavaScript, specifically for the Babel compiler, and the second one is the Haskell one. Well, actually, I haven't looked into the Haskell one, but I know the behavior of it. And third one, probably the hack. Hack is the kind of variant of PHP that built by our company, probably used by our company. And these three, because when you do the compilation process, the first step is to parse it and break it down to the AST tree. And once you found some error inside, like type check error, then you need to let the user know where this error comes from. So there's certainly a location mapping from the AST there's a mapping stored inside the AST node, or there's a way to map from the AST node to the source location, the node, the syntax, the term location inside the source file. So in order to make the compilation type checker specifically work as expected, there's certainly a way to have a map from those things, those AST to the nodes to the source file. So this is what I mean by the source mapping.
I see. Understood. Adler, do you know anything about these?
In Go, we don't need to worry about that. Just like how we check the line number, as I did it in the demo, that there's a part where you can specify saying, okay, when I parse this file, it will return a file set, and then with that file set, then we pass in saying, okay, tell me what's which line is that for this specific node. It can do that. So it's pretty convenient in Go that to retrieve this kind of mapping, like which node is at which line and which node is at which position, that kind of thing. Yeah, it's pretty convenient.
So it's already a built-in feature of parse set
built-in,
things like that.
Correct.
I see. Understood.
Yeah, because the Golang has types, so it needs to notify the user. So during this parsing process, it needs to store where this symbol comes from. So this information definitely stored somewhere, and obviously this API is exposed by the Go parsing library. So yeah, I can see that is foreseeable.
Yeah, understood. Yeah, thank you, Ray. Thank you for your question.
Yep, thank you.
Thank you for asking me this question.
And do we have more from the audience? Anyone want to ask questions? Okay, before we got more questions, like I used to build linter for JavaScript as well, and in the process we used to have a tool called CodeMod, where you can parse the source file and you can modify your code. For example, if we want to migrate from flow type to TypeScript, and then you can write your CodeMod, and the whole process is totally similar to the custom linter as well. Yeah. So I'm wondering, in Golang, do you guys have similar type of like CodeMod where you can write some like plugin where you can modify your code base? If you want to do like a big scale modification of your code base.
Yeah, I would say that would be very similar to what we talked about, saying you use the linter to catch a problem and then you fix it automatically with Go analysis package. That would be very similar. You need to find which part of the code is problematic, but I don't think there's a quick way of doing that, because fixing things requires very specific analysis of what's the problem you are solving and how to fix that. It's a very complicated process. But I think for things like Go format, the built-in tool like Go formatting is definitely using that kind of technique to help you format your code. For example, like if you have if you have multiple lines of import, then it will help you to order which should go first and which should go after which one. It's something that's already there, and then it's doable. All I just want to say it's doable, but it's not very easy.
I see. Understood. Thank
Yeah.
you for your answer.
Yep, all good.
All right, so no more questions, right? Oh, but I have one more, like I found from our audience.
Yep.
Saibai asked, because during your demo you mentioned you can implement your customized linter to remove some unused methods or modules.
Yeah.
And that Saibai asked, like that audience asked, why it's not a building feature of the language or of the building linter, things like that.
Yeah, I think that's a weird part of Go, saying that it considers unassigned variable, unused variable as an error, but it's not taking unused function as an error. I think that's an interesting concept, but I have no answer to that question. I don't know what they thought, what they're thinking, but they just probably they think that's not a big issue, but someone else say, hey, it's probably gonna be a big issue if you consider unused variable as the error, but unused function not an error. So someone make a tool for that and to amend that kind of issue.
I see. Understood.
Yeah.
All right. I think that's pretty much it about our presentation part.
Yep.
And thank you, Adela, again for your great presentation for us.
Yep. Thank you all.
Yeah, and for our audience, please take some time to fill in our past event survey, and our staff already post the link in the chat. And after this, we're gonna have another 30 minutes of networking time, and you can grab any seat you want in the social lounge. So I'm gonna end this session. For any of you haven't clicked the link, please take probably 1 minute to fill in our survey. And our speaker, Adela, will also join the table, right? You will, right?
Yep.
So if you guys have any questions, you can just find Adela's profile pictures in any table.
Yep.
And that's pretty much it. Thank you guys for joining today. Let's see you guys in the social lounge.
Okay, thank you.
All right, thank you. Bye-bye.
Bye. Wait, what should I do? Just leave?
You don't have to do anything.